Okay, so far in this unit we've been talking about polynomials. We've talked about end behaviors, we've talked about characteristics, we've talked about adding, subtracting, multiplying, dividing. Now we're going to look at the fundamental theorem of algebra, which tells us a lot about a polynomial. So the fundamental theorem of algebra basically says that whatever the highest exponent, which is the degree of the polynomial, that's how many roots it has. Roots are the same thing as zeros, x-intercepts, where it crosses the x-axis. So for example, if you look at a graph like this, let's do this. If we have a graph like this, right, this goes through 1, 2, 3, 4 times. So this would be quartic. So it would be an x to the 4th, which is a quartic. That's not the exact equation, but that's the highest degree for it. So that's what it would start with. Okay, so it's depending on the highest exponent, tells you how many times it crosses the x-axis, or how many roots there are. Remember, these are x-intercepts. They're roots. They're zeros. And their solutions. They all mean the same thing. So anytime somebody says, tell me the x-intercepts, tell me the roots, tell me the zeros, tell me the solutions, they're talking about where it crosses the x-axis. Okay? So that's what we're going to look at. We're going to look at some different functions here. First of all, sometimes a graph will cross the x-axis like it doesn't actually cross it, it just kind of touches down and goes back up. Right? That actually means it's hitting that spot twice. So what that means is, if it touches it like that, that means that this one has the root 2, right, with a multiplicity of 2. That means it touches it twice. So this, because there's 2, even though it only hits once, when it bounces off of it, that's like a double hit. So this means that this is going to be an x squared term, or x squared function, which is quadratic. Let me move up a little bit. Okay, so that's a little bit of our ahead of time information as we go through this. So let's look at, we said again that the fundamental theorem of algebra is that an nth degree, so depending on how high the degree is of the polynomial, tells you it has that many roots, or that many solutions, or that many zeros, or that many x-intercepts. Okay, multiplicity refers to the number of times the root is a zero of the function. We can have repeated zeros. So like when you solved quadratics back in Math 1, sometimes you got a repeated answer. That means it bounces off of that space. So let's look here. There's a few things that we want to look at when we're going to determine the degree of each polynomial, the roots of the function, and their multiplicity, and then sketch the polynomial based on the end behavior. So when we look at this, we want to go, there's a few things we're going to look at. First of all, we want to look at the degree, which is the highest exponent. The type of function is it quadratic, is it quartic, is it cubic, is it linear? Roots, which is how many solutions it's going to have. And then your end behavior we've been talking about, and your y-intercept. This will kind of tell us what we need to graph it appropriately. So first of all, looking at this, when you start multiplying this out, x times x gives you x squared, right? The only time you're multiplying an x with another x is right here. That's going to give you x squared. And see how there's 2 parentheses here? That tells us that the degree is 2, which gives us the type of it would be a quadratic. The roots. Your roots, remember, are the zeros. So remember when you change this, the opposite of this, and the opposite of this. So our roots are -1, x equals -1, and x equals 2. Where you set each one equal to 0. So you would do like x plus 1 equals 0, subtract your 1, and x equals -1. And you do the same thing, x minus 2 equals 0, add your 2, x equals 2. That's where these come from. In behavior, so in our previous days notes, or previous notes, they were day before yesterday, we talked about if it's a degree of an even degree and has a positive number out front, which x times x gives you 1x, that'll be positive, then your end behavior is as x approaches infinity, y approaches infinity, and as x approaches negative infinity, y still approaches infinity. Okay, so it's going up and up. The last thing we want to look at is our y-intercept. The y-intercept is when x is 0. So we would say 0 plus 1 times 0 minus 2. That's 1 times negative 2, which is negative 2. So our y-intercept is going to hit at negative 2. So let's plot. We know that x is at negative 1. That's right here. Right? X is at negative 1. We know that x is at 2, which is right here. And we know that our y-intercept is at negative 2. And we know we're going up and up because we're going toward infinity in both directions. So as this one gets bigger, we're going up here and up here. So it's going to look kind of like that. That's how you graph a polynomial given its characteristics down here. Okay? So let's look at our next one, B. All right, so we know we have an x that's being squared here, right? Because when you FOIL that out, you're going to get x squared. And then we have another x here. So x squared times an x gives us an x cubed. So this is going to be an x cubed type function, which is a degree of 3. If you have a degree of 3, that means it's cubic. Remember, we have linear, we have quadratic, we have cubic, we have quintic, or quartic, and then quintic. That's how they run. Okay, our roots. See how the x plus 1 is squared? That means it's going to be a double, so it's a multiplicity of 2. Negative 1, the opposite. And if you set this equal to 0, you just get x equals 0. So the roots are x equals 0 and x equals negative 1 with a multiplicity of 2. Our end behaviors. This is an odd function, right? An odd degree. And if you take x squared and times it by x, you're going to get a 1 out front. So it's a positive coefficient with an odd exponent, which means it's going to look kind of like, let me draw it here, like this. And you can see that from your notes from day before yesterday. So that means that the end behavior, as x approaches infinity or gets bigger, y gets bigger. As x approaches negative infinity, y gets smaller. So y approaches negative infinity. Okay? And the last thing again is your y-intercept. So if you put 0 in here, 0 times anything is going to be 0. So your y-intercept is going to be at 0, 0. So let's graph what we know. We know 0, 0 is the intercept, which is also one of our roots. We know we're going to hit negative 1 twice and see how it goes down. So we're going to do, it's going to be kind of a different one here. We know we're bouncing off of this, right? And so we're going to come scoop down like this. It's kind of weird to see how exactly to graph them, but you know you've got to come through 0, 0 and then bounce back off of that real quick. So that's kind of where that comes from, because the multiplicity of 2, the squared up here tells us that's happening twice, so we have to bounce off of it. Anytime we have a multiplicity of 2, we bounce. Okay? So let's look at the next one. I'm going to scoot over because it's a little blurry in that corner. All right, so first of all, this means there's 4. Squared and squared gives us the 4th. So x to the 4th is our degree. So our degree is 4. Our type is quartic, because that's a 4th degree polynomial. Our roots. Remember, it's the opposite of what's with your x. So negative 1 twice, positive 2 twice. So our roots is x equals negative 1 with a multiplicity of 2, and x equals positive 2 with a multiplicity of 2, which gives our 4 roots in total, our 4th degree. All right, so a 4th root with there's no negatives here, so it's going to look kind of like this in a sort. So we look at the number of times it crosses is going to be 4, but it's going to have this shape where it goes up. It's a positive number out front and even, just like we did with number 1 over here, positive out front and even, which gave us the in behavior of as x gets bigger, y gets bigger. Just like here, as x gets bigger, y is getting bigger. As x approaches negative infinity or gets smaller, y gets smaller, or gets bigger, I'm sorry, still, because we're going up and up. Okay, so now let's use what we know to graph it. We know we're going to bounce off of -1. Let's do our y-intercept, sorry. Y-intercept, if we plug 0 in for both of these, 0 and 0, that's going to be 1 squared, which is 1, -2 squared, which is 4. 1 times 4 is 4. So our y-intercept is 4, which is actually at 0, 4. So 0, 4. There's our y-intercept. We're bouncing off of -1, and we're also bouncing off of 2. So we know we're going bounce off, bounce off. So we should look like that. Okay? So there's our next graph. All right, so let's keep on moving here. All right, this should be a fairly simple one for you guys. X plus 1 is just a first degree, right? The only x that's here is here. So that means there's only one x, or first degree. If you have a first degree, that means it's linear, right? That's in y equals mx plus b form. Our roots. In this case, it's going to be linear. It's easier to graph linear, in my opinion, without really doing the roots and stuff. So I look at linear as saying my y-intercept is the b part. So that's 0, 1. So we're going to go to 0, 1. Remember our slope, rise 1, run 1. So this one's a fairly easy one to graph. There we go. So as x gets bigger, as x approaches infinity, as x gets bigger, y is getting bigger. As x approaches negative infinity, y is approaching negative infinity. Because as x gets smaller, y is getting smaller. Okay? So I want you to pause for a second and try this out on your own. I want you to see what you can do. Try out parts E and F and resume the video once you get them done.